We're going to be making a system for saving and then loading game data. Okay, obviously the needs of your own game are going to vary, but if you understand this video, I can all but guarantee you're going to be able to use what it teaches you to save and load whatever kind of data and whatever structure of data you need to be able to save. This should more or less be the last saving and loading tutorial you need. First of all, the contents of this video are only going to work with GameMaker Studio 2 version 2.3.1 or later. At time of recording, this version is in beta, but I suspect maybe not as soon as the video releases, but very shortly after that, it's going to make its way to stable very, very soon. If you're looking for something that works with older versions of GameMaker though, check out the video I link in the description. So obviously here we're saving quite a lot of data. We're saving a whole bunch of instances, their position on the screen, their color blend, whether it's a picture of my cat or a picture of a dog, and so on. Okay, so we've got quite a varied selection of data there to save. So in order to do this, we're going to save our game as a JSON string. JSON is just a way of structuring data in a human readable way. That data will be made up of arrays and structs inside of GameMaker. An array being a simple ordered list of variables that you reference by number, and a struct being an unordered list of specific variables that you reference by name. We can nest structs within arrays and arrays within structs to create pretty much any arrangement of data we could need. Inventories, object positions, health, upgrades, you name it. For our project and our bunch of weird animal heads, we're going to save and load an array that's filled with a struct for each one of these heads that will contain the position, color, and spinning speed of all of our things. And if you're going to understand how to do that, how to save that out, and how to load that back in, you can load and save pretty much anything. What happens in the rest of this code isn't really relevant. All we're going to be worried about today is what happens when we press the L key to load the game and when we press the S key to save the game. Although if you are interested, there'll be a link in the description where you can acquire the full source code for this. So I'm going to maximize this, and we're going to focus first of all on what should happen when we want to save the game. So the first thing I want to do is make an array in which to save all of our data. Okay, the root of our data is going to be an array, and then each entry of that array is going to be a particular entity that we want to include in the data. Okay, so make a save array is the first thing we're going to do. Var underscore save data equals array underscore create 0. Okay, that's just going to create an empty array with 0 entries in it for us to actually put our data into. Next up, what we want to do is for every instance, create a struct and add it to the array. So for every instance that exists, which in this particular game happens to be every object out of those cat and dog heads, they are all child objects of a parent object called P save me. That might not be the case for your game. You might have to do like a few of these loops with different types of objects or however or whatever it is you're doing to save your game. This is just what we're doing here, okay? So we're going to go through every instance of P save me, which is, you know, those cat heads and those dog heads, and we're going to create a struct that contains the information about them that we want to save, which isn't going to be everything about them, just what we want to save, and then we're going to put that struct into the array that we've created up here, okay? So to create the struct, I'm going to write var underscore save entity equals. And now, rather than putting something on the end of here, we're actually going to press enter and open another set of curly brackets. This is how we define a struct, okay? Because we're not defining save entity as any one particular value. We're defining it as a set of values with associated property names, okay? Just like how an object has X, Y, and so on, right? The properties we're going to define, first of all, we're going to define what type of object it is we're saving, okay? And we're going to write obj, and then rather than type equals to define like a value, when we're defining a property of a struct, we use a colon, okay? So I'm going to write obj colon and then object underscore get underscore name object index, okay? And then a comma on the end because it's going to be a list of properties, and on the end of each one we want to put a comma, okay, to show that we're not done yet. The next property I'm going to store is y, so y colon y. Don't worry about the fact that this turns green. It threw me a little bit at first, but we can still use that to define the name of a property even though it represents a built-in value. And then when we get y here, that's going to get the y position of the instance itself. Next is going to be x, which is going to be the x coordinate of this particular instance. Oops, why have I typed y? It's going to be the x coordinate. SPD for speed, which is going to be the exact same variable from this object, SPD, which is its spinning speed. Image index colon image index and image blend. It just helps us to stay consistent. We may as well name the properties the same thing as the variable that we're putting in, okay? Now that we've defined this struct, what we could actually do at any point, really, while we've got access to it, is if I write _save entity dot obj, that's going to be equal. It's going to return whatever is in this property, which will be our object name, okay? Just the same, obviously, if I write speed, it's going to get the speed that we put into it from whatever instance we're currently working with, and so on, okay? That's how we operate with structs, okay? If we want to reference any particular one of those data, it's just how, like, when you work with an array, like save data, to get a particular element of that array, we would type a square bracket, like 5 or something like that, right, to get the 5th entry of the array. That's the difference between working with a struct, which is a list of values, and an array, which is also a list of values. A struct is unordered, but is named by specific variable property names, whereas an array is in a strict specific order, but is referenced by number. Okay, this next line is kind of why this tutorial only works with version 2.3.1 specifically, because we've got a bunch of new functions for working with arrays. The one we're going to use here is called array_push. What this does, it's going to add a particular value to an array on the end of that array. Okay, so currently we've got nothing in the array, so it'll go to entry 0 in the array, but then the next time we call it, because we're going to go through every instance of pSaveMe we have, every time this happens, it'll happen in a bit of a loop. It'll go to entry number 1, number 2, number 3, and so on every time we call this. So we're going to call array push, and I'm going to write save data is the array that we're pushing to, and the value that we're pushing to it is _save entity. Okay, so we've got this struct, which is all the properties of a particular object, and we're going to just push that into our array. So now, when we call it, say we only have one of these, save data, open square bracket 0, that for the first entry of that array will contain a struct that will contain all the properties of that particular instance. All right. Now, just by calling this and by doing with pSaveMe, it's going to do it with every single one of those instances. So once this is all done, and once we're at this point of our code, we actually have now got an array filled with every instance in the game room and all the data that we need to save. So we have everything we need to save now, all in this one array. So now what we need to do is turn that data into a JSON string and save it. As I said earlier, JSON is just a file format, okay? It's a format, it's a way of putting data into a file that is basically recognizable in this kind of format of arrays and structs, okay? And since this is a very similar sort of data, we can very easily use functions in GameMaker to convert our actual data into just essentially a text, human readable string that represents all of this data, okay? And then we can save that text string just out to a JSON file, all right? So we're going to turn all this data into a JSON string and save it via a buffer as well, which you'll see what I mean by that in a second. But the first thing I'm going to do is do var_string equals JSON stringify, open brackets, _save data. Now, JSON stringify is basically the arrays and structs version of what exists, a function called JSON encode, which would normally work with DS lists and maps to turn those into a JSON, okay? But if we're working with just arrays and structs, we use JSON stringify, which does the exact same thing, but with arrays and structs, okay? And it's just going to turn it all into one giant string that we can save to a file. Now, rather than use some of the functions that exist in GameMaker for making text files, which would work for this, on Windows at least, like file, text open, and stuff like that, I'm actually going to save this via a buffer, okay? Buffers are just like packets of memory that you can create, which are very useful when you're holding, like, well, as a buffer, literally, to like hold data in one specific place while you change it from one type of data to another, and in this case, saving it out to a file. Okay, the reason I'm doing it this way, even though it's a little bit less intuitive if you've never worked with buffers before, is because it's a lot more cross-platform compatible. Okay, if you are making a game for console or something like that, you might run into problems if you use the functions that are designed specifically for working with Windows files, which is things like the open text file functions and stuff like that. Okay, it's generally a bit more compatible just to use buffers. You don't have to know how it works really. It's only like a couple of lines here. You'll get the idea of what it does, and that's all that you'll really need to know. So I'm going to write var underscore buffer equals buffer underscore create, and then string byte length underscore string +1 buffer underscore fixed 1 close bracket semicolon. Okay, I don't think I'm really going to explain this line in great detail. You don't need to worry too much about it. You can look into it if you want. Just middle click each one and it'll tell you what they're doing. But all I'm doing is creating a packet of memory, defining the size of that memory, which needs to be the amount of data we're going to store. Okay, that's what I've done here, string byte length, string +1. The type of buffer that it is, again, you don't need to worry too much about it, and it's alignment, which is you can look into that stuff if it interests you, but all you need to know is that this is the line that you need to type in order to save a string of data, which is all you're going to need, no matter what type of data you're going to save, really. And it's all going to turn into one giant JSON string, and it's going to use the same type of buffer. Okay, so don't worry too much about it. Then buffer underscore write, open bracket, buffer, the buffer we just created, buffer underscore string underscore string, close bracket, semicolon. Then buffer underscore save, let's just make some space down here, underscore buffer save game.sav in quotation marks. Okay, so we write the string to the buffer, defining what type of data it is that we're writing to it, and then we save the buffer out to a file by doing buffer underscore save. Okay, we define the buffer that we're saving, and we just give it a file name, and it'll save it as that. All right. Save game.saving. You can put whatever extension you want on the end of here. Save just seemed appropriate because it's a save game. And then we delete the buffer because we don't need it in memory anymore. So buffer underscore delete underscore buffer. Okay, hopefully that didn't seem too complicated and you get the basic idea of what it's doing, even if some of this is a bit like, whoa, what is all of that? Okay, and then just at the end here, I'm going to write show debug message, game saved, with a space, and then plus underscore string. So once we've actually run all of this code, it'll output a little message in our output window. Just when we're running within GameMaker, it won't do anything to like your final executable or anything like that. But it'll show, and there's this little output window, a little message that'll say game saved, and it'll output the string of JSON data, just so we can check it for any problems and we can see it's all correct. So we can actually run that now. I'll press F5, compile that, run it, play some stuff around the game, and press S. And we can see down here now, after doing that, we've got game saved, and all of this data has just come up. Okay, we can see like just, I'll zoom in here, and you can take a closer look at it. We've got like square bracket, and then like that's signaling the start of an array, or a list in JSON, and then a curly bracket, which is denoting the start of a struct or an object. All that information about one particular thing, and you can see here where it like closes the curly brace and creates a comma, and then opens another one, and it creates another entry in the array over here, and there's another one over here, like another object that's being saved. So you can see all the data is being saved correctly. You can go over the whole thing and be like, yep, those numbers match up to the things that we placed on the screen. That's all correct, and that's been saved out to a file now. If we went to the 10th folder that this gets running or whatever, we would find a little file there called savedgame.save. Okay, so we have that stuff being saved. Now we just need to actually load it back in. So if you've been following along pretty well so far, the loading part of this is actually very straightforward. First of all, what we're going to do is erase our current game state by just deleting any objects that happen to be here, right? So with p save me instance destroy, how all that works will vary for your own project, right? But we're just going to clear everything out just so that we can load our data back in. So if file exists, saved game.sav, .save I think we called it, right? Then do a loading. If it's not, we'll just do nothing. That's fine because there was nothing to load. Okay. So if the file exists, we want to first of all do var underscore buffer equals buffer underscore load. Open bracket saved game dot save. Close bracket. Okay, and then we're going to do var underscore string equals buffer read buffer string. So when we call this, it's going to load the contents of this back into the buffer that we created and saved into the file in the first place. So we have, and we don't have to do any more fancy definition stuff, okay? Because it's gonna work out based on the contents of the file, what type of buffer and everything that is, and it'll put it all into this buffer variable. And then what we're going to do is create a string, and that's going to read the string out of that buffer so that we have it back in string form. Okay, just in regular readable text string form. Then we don't need the buffer anymore, so we can do buffer underscore delete underscore buffer because we have it all in the string. And then we just want to convert that string back from just a pile of text that we were saving out back into arrays and structs, okay, or in this case an array containing several structs. So I'm going to write var underscore load data equals JSON underscore parse, open bracket string, close bracket. Okay, and that does, as you might imagine, the reverse of JSON stringify. Okay, whereas JSON stringify took our array full of structs and turned it into a JSON string, this takes a JSON string and turns it back into an array full of structs. Okay. So we have all the data back now. We have all the data just chilling in underscore load data. So now we just need to use that data to actually put our instances back into place. Now this point will obviously vary on your particular game. Once you've got the data, you just need to do whatever your game needs to do with it to get your game state back. And in my case, that will look something like this. Okay, so this is what we're going to do to get the data back into our game. We know that load data is going to be an array because that's how we structured it when we saved it. Okay, we have an array full of individual structs. So we know that this is an array, so we can just cycle through it until that array is out of entries for us to actually load back in. We're going to use another one of these fancy new array functions in 2.3.1, this time array underscore pop. What this does is it gets the last entry of the array, returns it, and then removes that entry of the array. Okay, so it's like a 2-for-1. We're going to get the last entry of this array, we're going to put it into this variable, and then we're going to remove it from the array. So we're slowly melting our way through the array until the array is empty. Okay, so we get the last entry and we put it in here. And we know that every entry of this array is a struct. Okay. And so what we can do is for every one of those structs, we're going to create a object based on whatever type of object that struct wants us to make. Okay, because you remember we saved the name of the object. All right, we saved what was it called? Object get name. Okay, which will actually be like a string if I remember. Okay, and in this case will be like thing as a string. Okay, and since we have that string, we can use asset get index and pass in load entity dot obj. Okay, we've got that struct, and now we just refer to obj within that struct to get the name of the object. Pass that into asset get index, and that will create an instance of thing. Okay, we put it at 0, 0 on whatever layer. That's fine, and then we just define its various properties because we've done with this instance create, we can now modify its properties. So we're going to set x to equal loadEntity.x, y to be loadEntity.y, image blend to be image blend, image index to be image index, and speed to be speed. All right, and that's going to get all that info out of the struct and into this new instance. Then once we've done all that, because this will just keep going until we're out of data to load, we're going to show another debug message that just says game loaded and pastes the string of data again, just so we can make sure we're getting the same data back that we originally saved. And that's everything. That's all there is to it. So that's the key press L and the key press S functions. Let's run the game now and just demonstrate that all working. I can place a couple of things here. So we've got like 2 red dogs, a green cat, and a fast spinning red cat there. I'm going to press S to save it. You see game saved, all that data came up. I'm going to close the game down entirely just to make the case explicitly. Load it again, press L, and it's going to load that back. And then if we scrolled back up through here, we'd see this text in our output window is exactly the same. We've got 2 red dogs, green cat, fast spinning red cat. We can add some more stuff, save it, press R to restart the game, load, get it all back, add some more stuff, L to get it all back, and so on. It works pretty much flawlessly. This is obviously just one example of saving and loading data, but at the same time, like if you understand the fundamentals of how this stuff works and how arrays and structs work, you can create whatever structure of data you want to save and save it in this exact same way, just as a big JSON string that contains all the data that you need to save it out, convert it from a series of arrays and structs into a big JSON string, save that string via a buffer, and then when you need to load it, load that buffer in, turn that JSON string back into arrays and structs, and then use those arrays and structs to restore your game state. Okay, that's the flow of it. That's all you really need to understand. If you follow how that works, you'll be able to create whatever game save and load system you want. All right, hope you enjoyed that, guys. Thank you very much for watching, and I'll catch you all next time. A huge thank you to my Patreon supporters, as always, and a huge thanks in particular and in no particular order to the following: Elizabeth and Landon Brown, James Ballard, Gage Hunter, The Game Guru, Julian Cropley, Cadin Shino, Darnell Braxton, Michael Kolich, Tim Tharman, John Kenai, Stephen Chenier, Borgia MK Ultra, It's Matpour, Hello Winter, Rachel Stewart, Arctics, Feral Princess, John C, Team D, Mr. Oars, Jordan Hake, Dalvor, Vacants, Phil Keen, Pong Pong Zhao, Andrew Gilbert, The Holtzman Effect, Kaiser Ho, Boris the Wizard, Zach Collett, Figgy, Cabbage Pants, Joram Pater, Leo, Scott Matthews, Mark Burgess, Samir Nyayaleggaglow, Rene Dam, Rupinder, Hare, Dark Rider 0318, Jason, Relentless Rex, Bertie T, Daka Dondigo, Robert Churches, Baz the Dog, Scott Ewing, Max M, and Zephyr Flame. Thank you all ever so much, and thank you for watching and supporting what I do. Catch you all next time.